So in this video we're going to review what an unconformity is as part of chapter 6 here in Earth Science. So when you look at a geologic sequence or a layering of rock structure, if there has been erosion that has occurred along the surface and then that has been reburied with new sediment, you have what is known as an unconformity. It is a missing part of the geologic record. Weathering and erosion will wipe away layers of rock, forming a gap in the timeline. So here we have a couple of photos, and we'll see some more in a minute, where you have a definite change from rocks that are kind of aligned this way to something occurring where the rocks are now aligned going across. This area here would be the unconformity. In this photo on this side, this layer here would be known as the unconformity. So it changed from one type of structure to another by erosion. So here we have a little animation that will show this to us. So we have deposition occurring under the sediment layers, and they build up those horizontal layers. Folding and uplift occurred, and then the erosion occurred, and on top of that you have new layers. So that's where the unconformity will be formed. So this layer here, they drew in that I'm kind of highlighting, is the unconformity, right? And if you looked at, say, this layer, it stops. It should continue, but that's been wiped away. That's been eroded away. So this part here is gone, and that missing information is why the unconformity is worth paying attention to when you deal with a layering of rocks. You're trying to determine the kind of story of the event or the order in which they formed. There's a missing layer. So here's more of a drawing you might see on a Regents exam, and you have layers that are all parallel but tilted, and then you have layers going across the top that are parallel in a different direction, and you can see that the unconformity here is this right here. This is the change from one type of rock structure to another. And on the diagrams for the Regents exam or in textbooks or whatever, they are usually drawn with a little black wavy line. So here's a photograph of something almost identical. And you should be able to pick out the unconformity very simply and very obviously. Okay, again, you have layers going parallel in one direction, and then above that you have a totally different type of structure. So this looks like one big giant sedimentary deposit, and therefore your unconformity would be right here. So there's your unconformity. It is something was up here, it's been eroded down to this layer, and then reburied with this looks like conglomerate or breccias, some sort of sedimentary stone. Another good example, should be pretty obvious where the unconformity is. Okay, right through the middle here you have a big change. Okay, this one is off a Regents exam. You can see they drew it in the more, conventional way. You'll see it more like this often, where it's just a dark wavy line showing you where the unconformity is. And at this point you should be able to recognize that there's also a fault line running through here. So this, I'll highlight the fault, and the fault has also kind of ends at the unconformity, which means the fault was here and then erosion erased everything about the fault, and then when these fresh new layers, okay, when this new layer here and these new layers got placed on top, they completely buried the evidence of the fault or this rock layers from below. Okay, same idea through here. In this particular diagram, they didn't draw the wavy line as bold, but you can see since the intrusion has just been wiped clean, has just been cut off, you know that erosion happened. And that clue there, that area right there, is your reason to know that this line is an unconformity. Something eroded it down to this point, and then the shale was built on top of it, was deposited on top of that. Okay, this is the animation we watched in class, and within this animation you can see several unconformities being made. Again, lots of deposition occurring. 6, 7, or 8 layers will be formed. And as soon as you have erosion happening right after this fold, so right at this point, starting now, you have erosion. This erosional surface, the other name for an erosional surface is, the surface of the earth. It's where things are wandering around. This process is incredibly slow, taking hundreds of years in some points. So here we have more erosion occurring. At this point in time, this is the surface of the earth. Any creatures here in this ocean, their remains and fossils will be in this layer. And now it is buried. So now we're looking at 2 unconformities in this particular diagram. This surface here at the top is not an unconformity because it has not been buried. This is just erosion. This is what we could call an erosional surface, where the rain, snow, and all the weathering from the previous chapters is washing away the surface. If it were to get reburied with new layers, then yes, this would also become an unconformity. But it is not yet, so it's just the surface. Here we have another photograph of one, and another where there's obviously a change from layers that are going this way to the surface, the current surface, which is another way. Okay, you can see that the type of rock here is very different than the type of rock that's up here, and I shouldn't pick yellow anymore. Type of rock that's up here. So there's probably some sort of unconformity right along here, separating the two. Okay, you should be able to point out which letter the unconformity is. By looking at this, you'll see a whole bunch of things. We see an intrusion and lots of metamorphism. We see the surface has been eroded. We see lots of layers, and you could argue there would be possibly 2 unconformities in this particular drawing, but I would highlight this one right here, where layers that have been going this way have been eroded, and you could possibly argue that W through here is also an unconformity, where layers that were at an angle have now been wiped clean and a new horizontal layer is placed on top. Okay, another way to show it in simple drawings. Here we have an intrusion breaking through with no unconformity. This diagram is way more involved. We have a fault that's been buried after a cut through an intrusion with an unconformity here in the middle. So overall, an unconformity is a buried erosional surface. Intrusions, extrusions, folds, and faults are always younger than the layers they disturbed. Hope this was helpful, and I'll see you in class.